I'm going to talk about imaginary numbers in this video. And if this is your first time kind of learning about imaginary numbers, they're kind of funky, but you'll find that they're actually pretty easy. All the operations and things that we do with regular numbers will help us out when we're working with imaginary numbers. So what is I, or what is an imaginary number? And imaginary numbers come from the fact that whenever we want to square root something, like let's say the square root of um, 16. That's a nice even number because 4 times 4 gives me 16. That would be 4. But the problem is when we take the square root of something like negative 16, there's no nice perfect answer to that. There's no, a positive times a negative gives us a negative. So how could we ever find the square root of a negative number? And that's where imaginary numbers come in. Imaginary numbers come from negative square roots, and I, or this imaginary number, is defined by the square root of negative 1 is equal to I. So we just defined in mathematics that the square root of negative 1 is equal to I. So we'll fill that in over here. So I is equal to the square root of negative 1. Now, remember that anytime you square something, it's kind of important to look at what a few different powers of I here are. If you square anything that's square rooted, like for example, if I have the square root of 3 and I squared it, the radical would just cancel with the square and I'd get 3. So if I actually take I squared, that would cancel the radical and I would just be left with negative 1. So the I squared is equal to negative 1. And then I to the third can be calculated pretty similarly. If we split this up, I to the third we could rewrite as I squared times I to the 1, or I. And then remember that I squared, we said, is just equal to negative 1. So I to the third, you may see here, is just the opposite of I, or negative I. Okay. We got one more to go. We'll do I to the fourth. Okay. I'm actually going to split I to the fourth up into I squared times I squared. And remember that I squared is negative 1. So I to the fourth would just be 1. And this is just a helpful thing if you didn't understand my explanation. For now, just kind of get that down in your notes. This is what's important here for now. We'll get into different times when we use this in a little bit. All right, so we define I, or imaginary numbers, as occurring when we take a negative square root. Okay, so what we're going to do is simplify some square roots into some imaginary numbers, and we'll do that just like we would a normal square root. So if you look at the opposite of 81 under the square root here, what I can do is I can split this up into negative 1 times the square root of 81, both under the radical. We know that the square root of negative 1 is I, and the square root of 81 is 9. So we would just write this as 9I. It's really the exact same thing as the square root of 81, but since it has the negative, we bring the I out. Okay, we're going to do this one very similarly. We're going to look for the biggest perfect square we can take out, and in this case it's going to be 25. So we'll rewrite this as the square root of negative 25 times 2. Again, that negative sign is going to bring an I out, and the 25 will bring a 5 out, so 5I will come out, and the 2 is left under the radical. Okay, we'll do one more here, negative 7. So 7 under the square root, we can't really take anything out there, but we can take that negative out. Again, if we want to write this out the long way, we can split it up. This would be I root 7. So anytime we have a negative square root, it's going to be an imaginary number. We should have an I out there. Okay, so we can also do some operations with complex numbers as well. So if I had negative 9I in parentheses squared, what I can do is follow my rules for squaring things and figure this out. So if I square the negative 9 here, I should get positive 81. And if I square I should get I squared. And you may think that's your answer, but actually if we flip back here for a second, we said that this I squared is just equal to negative 1. So I'm actually going to take this one step further. Since I squared, so a nice thing to remember here is that I squared is equal to negative 1, we can rewrite this as 81 times negative 1, which is just negative 81 for our answer. So anytime you have an I squared, it's a good idea to replace that with a negative 1. Okay, we'll keep on moving. We can add and subtract. This is actually called a complex number. It has both a real part and an imaginary part. And they go in this form a plus bi, okay, where the real part comes first and the imaginary part comes second. And most teachers will like to see complex numbers written with the real part first and the imaginary part second. So let's go ahead and simplify this. This works just like you would with like terms, so if you're familiar with that, that should be easy. So I'm going to start by distributing this negative sign in here first, which should give me 2 plus 3i minus 4 minus 2i. And then if we just combine the like terms, 2 minus 4 is negative 2, and 3i minus 2i will just be a positive I. So notice the real number part comes first, and then the imaginary part comes second. All right. Next one. What we'll have to do here, this is like a FOIL problem, so we're going to have to actually FOIL this thing out. So I'll take 1 times the first term here, we get 2, minus 5i, and then for this one we'll get 4i minus 10i squared, so here's where you have to be careful. If we combine the like terms here in the middle, I should get 2 minus 1i, or I, minus 10i squared. And a lot of people at this point may think you're done, but remember back to this problem. We said that I squared is negative 1. So if we actually kind of go back, we can plug in here a negative 1 for I squared. So I'll do just that. I'll get 2 minus I. I'm going to make that a plus 10 because if we made this a negative 1, negative 10 times negative 1 would be a positive 10. And now I can just combine and make this look a little bit nicer. Notice that my real part came first, the 12, and the imaginary part came second, the minus I. Okay? And sorry if you can hear the cat. He's going crazy in the background here. So finally, we'll solve some equations here with imaginary numbers. We've got x squared is equal to negative 8 for this one. Okay, so we'll solve away. And if we do that, let's check it out. So we've got to square root both sides first to kind of isolate the x. That'll give me x is equal to, and if we simplify the square root of negative 8 here, we would probably want to split this up into the square root of negative 4, that's a perfect square, times the square root of 2. And then the square root of negative 4, well, 4 is just 2, and then the negative sign means we need the I there, so it would be 2i root 2. Now there is something I forgot here, so let's see if you guys caught it. Hopefully you did. And I did this intentionally just to see if you're paying attention here. But remember that just like before, when we square root both sides of an equation, even if there's an imaginary answer, we need a plus or minus sign here to solve that. So the positive 2i root 2 and the negative root 2i root 2 would both be solutions to the problem. Okay? One more to go here. We're going to add 27 to both sides first to start getting things by themselves here. So we'll get 3x squared is equal to 27. And then finally, if we divide by 3 on both sides, we'll get, oops, that's actually not going to have an imaginary solution, but that's okay. So we'll have x squared is equal to 9, and then we'll have x is equal to plus or minus 3. So that one does not have an imaginary solution. What I probably should have done, and let's go back and do this here just to get an imaginary answer out of this. But that's how you would solve a normal one. If that was a positive 27 here, then we would have to subtract 27, and we'll get 3x squared minus 27, equals negative 27. We would then have to divide by 3, so we'd get x squared equals negative 9, and then you can see here, if we square root both sides, we should get x is equal to plus or minus 3i. Okay? Introduction to imaginary numbers. They're kind of funky, but the big thing to remember when you're simplifying them is that I squared is equal to negative 1. Other than that, again, just most of the rules of regular numbers apply. You just have to follow your rules.